this one we're going to look at example 2b, and I hope I wrote it down right. Looks good. Okay, so this one here, again, what I said in the last one was when you see brackets, you should be looking to see if they're the same. And in this case, they actually aren't the same. But we only have a binomial. I know it looks like there's more going on there, but technically you have a piece here with a subtraction and then a piece there. So when we have difference of squares, we don't need to have the variables be the same when there's only two variables. Okay, so that's why we can still use the brackets, but we can substitute them for different things. So I'm going to use P and Q. So I'm going to let P equal 2t plus 1. Don't use the squared with that, okay, because you need the squared in the difference of squares. So we just use what's in brackets, okay? And I'm going to use Q is going to be my S minus 2. So now I can substitute in those letters P and Q. So this statement here will become 9p squared and then minus 4q squared. Okay, give me a nod if you're okay with that. Okay, perfect. So now what you're looking at is this is quadratic. It's got squareds in it. Okay, so we start with order. Well, order doesn't really matter in difference of squares other than that you want to make sure that you have that middle term is going to be a negative, so sometimes you have to rearrange them or pull out a greatest common factor. We don't have a greatest common factor in this one, so now we're at the spot where we say, okay, is it a binomial, trinomial, or four terms? It's definitely a binomial, so we check for difference of squares. Okay, how do we know that this is difference of perfect squares? Well, you have your difference, because you have your minus in the middle. Okay, do you have perfect squares? So 9 and 4 are perfect squares. You can square root them. We don't care about the negative part with the square rooting there. And then p squared and q squared are also perfect squares. So we're good with that. Okay, so now the rules for difference of perfect squares are that you square root the beginning term to get the beginning term of each factor. So I square root 9 and p squared, and I would get 3p. That's going to become the beginning of each of my factors. Then I square root the second term to get the second piece of each of my factors. So I square root the 4q squared, and I'll have 2q and 2q over there. I have to have a plus and a minus. That's how come I don't end up with three terms when I do distribute these out, because the two middle terms combine and they become nothing. Okay, it's also how come I get a negative in front of my second term on my original difference of squares. Okay, I'm not done the question yet though, because I do have to substitute back in the values that I had there. Okay, so the values I had, again, I'm going to go with some square brackets. It'll be 3 times by, and my p was 2t plus 1. And then I'm going to have, so that's this first piece, now this second piece, plus 2 times by q, and my q was an s minus 2. Okay, see if you can get the second bracket on your own if you're one of these people that's copying it down right now, and I'll just do mine silently here. Okay, does everything look okay from what I wrote down up here? Okay, and now we can get rid of some of these brackets, so we will distribute 4 times. 1, 2, 3, 4, and we'll see if we can simplify things a little bit. Okay, and when I distribute, I can get rid of that square set of brackets, so that's what I do. So I'd have a 6t plus 3 plus a 2s minus 4. And then on this side, a 6t plus 3 and a minus 2s plus 4. That distribute that negative out both times on that side. If you see any mistakes, raise your hand. Alright, and then combine like terms. So you can combine the integers in each set of brackets. Okay? So this one will be 6t, I'm just going to put my s's next, plus 2s minus 1. This one will be 6t minus 2s